All right, folks, it's Bass Action back in action here. In this video, we are going to go over all the properties of what happens when segments intersect both inside and outside a circle. There's going to be a lot of relationships that happen there, and we're going to cover all those possibilities. There's going to be a lot of algebra happening in this video. So if you get lost on any of the algebra, pause it, rewind, and if you're still confused, make sure that you come in for some help. All right, let's jump into our first example here. We're going to have a tangent and a radius. I want to draw your attention to the fact that each of the examples are going to have a verbal explanation of the theorem. If you like this verbal explanation, great. And if you don't worry about it. Some of you are going to be more visual and you'll be drawn to the pictures, and some of you might actually like all those words. So if they confuse you, don't worry about them. So we've got a tangent and a radius. Our picture would look something like this. What we want to understand is that when we have a tangent connecting at the point of tangency to a radius, that we will always get a nice right angle there. Now, when you draw these pictures yourself, you're going to want to make sure that you put that right angle in there, because sometimes it's not going to look the same to us. It's not going to look like a right angle. Then we're going to remember that all the radii in a circle are congruent. So we can fill in an X on both of these pieces since we don't know what the radius is. From there, we can just work with the nice right triangle that we've got happening here and do a Pythagorean theorem. So we're going to square our legs so that we're going to have an X squared plus our 24 squared. And then for the hypotenuse, we want to remember that we need to look at the entire hypotenuse, which is going to be x plus 18. So then when we do our x plus 18 squared, we want to make sure that when we're solving this algebraically, that we remember to expand and FOIL that entire right side. So I'm going to keep this x squared plus 24 squared here, and on the right, x squared plus 36x plus our 324. Now, if you forget to FOIL, your variables are going to drop out and you're going to be confused. So this way we can see that the x squares are going to cancel, and now we can take that 324, subtract it from each side, not forgetting that that's a 24 squared there, and on the left we're going to get 252 equals 36x. So our x on this problem is simply 7. Okay, so that's our first possibility. The next one is going to be if we have two tangents that are intersecting the circle, but they're coming from the same point. So we've got some points of tangency here. Might not look super perfect because I had to hand draw this, but if they're coming from that same point, these two segments will always then be congruent. So this one's going to be pretty easy. You just take those segments and set them equal to each other. Algebraically on this problem, since we've got our squared term here, but it's not going to cancel out, we need to remember that we need to use our quadratic, not our quadratic formula, that it's quadratic, and we want to move everything to the left. Of course, we could use a quadratic formula, but remember, we've talked about this in class. All of our values, all of our trinomials for our quadratic should factor in this class, that we're really trying to focus on that factoring skill. So we're going to factor this x minus 8 and an x minus 2, which gives us two values for x of 8 and 2 when we set the factors equal to 0. All right, now our next one, this is where things are going to get a little bit more complicated in deciphering our pictures. This is what's going to happen when we're going to have two chords intersecting. What we want to be able to do is identify the parts of the chords as they intersect. So I'm going to have a part right here and another part right here. That will give me this x plus 10 and this x minus 1. And then I'm going to have a part here and a part here. So that's going to be a 4 and a 5x minus 1. This theorem tells us that the product of the parts will be equal. So in other words, x plus 1 times x plus 10, that product is equal to 4 times 5x minus 1. So algebraically, we're going to have to do a whole bunch of expanding. On the left, we're going to FOIL x squared plus 11x plus 10. On the right, we're going to distribute the 4, 20x minus 4. Again, we have a quadratic, so we've got this quadratic. It's not going to cancel out, so we're going to move everything over to one side. X squared, we're going to have a minus our 9x plus a 14 equals 0. So we'll have an x minus 7, an x minus 2, set each factor equal to 0, and we get x equals 7 and 2. All right, we've got 2 more examples to do here. Now we're going to look at what happens when segments intersect outside the circle. Okay, so now we're going to have some secants intersecting. We still want to find some parts, but this time what we want to draw our eyes to is the portion that's outside the circle and the portion of the entire secant. So on this one, our outside piece would be x minus 1, and the entire secant is x minus 1 plus this 13 that's on the inside. So we'll add the outside and the inside to get the whole secant is an x plus 12. On the other side, for the other segment, we're going to have our outside piece and our whole piece, which means our outside piece is x, and the whole is an x plus a 4, or in other words, a 2x plus a 4. Again, the product of those will be equal. So the product of the outside piece times the whole piece is going to be equal to the product of the other outside piece times the other whole piece. And now we're going to start expanding again. On the left, we're going to FOIL x squared plus 11x minus 12. Then on the right side, we're going to have 2x squared plus 4x. Now, our squared terms again are not going to cancel, so we need to move everything to one side or the other. Since I have a bigger x squared on the right-hand side, I'm going to move all of this to the right. So I move that to the right, I'll have a 0 and an x squared minus a 7x plus a 12. Now we're going to factor again. X minus 7, x, oops, didn't mean to say 7 there. Sorry about that. Let's erase that. How about x minus 4? I was looking at the 7, got ahead of myself. So x minus 4 and x minus 3. Set each factor equal to 0, and we get 4 and 3. Our last one is actually, it looks very, very different, but it's actually the same idea. We're still going to have an outside and a whole, but this time we're going to have one of our segments is going to be a tangent and one is a secant. Well, on the tangent, the outside piece and the whole piece are going to be the same. So we would have an outside piece and a whole. So what we would end up with is a 6 and a 6. On the other one, we will have an outside piece. So I'm going to have my outside piece and I'm going to have my whole. So my whole is a 15. It's a little easier one to fill in first this time. And I know the whole and I know the inside. So I have to do a little work to come up with an expression for that outside piece, and it will be 15 minus x. Again, their products are going to be equal. So the product of the two tangent pieces is going to equal the product of the outside piece for the secant times the whole piece for the secant. So on the left, we're going to get 36. On the right, I'm going to distribute that 15, and I'm going to get 225 minus 15x. I like my variables to be positive, so I'm going to kick that 15 to the left and get a 15x. I'm going to move the 36 to the right and get a 189. So my final answer for x is 12.6. Now, we're going to do a whole bunch of practice with this in class, But the main thing that I want you to be thinking about before you get to class is, are you comfortable with all this algebra, or is there any more practice or help that you think you might need before we jump into more problems like this?